Alrighty. Okay. Yeah, y'all see the graphs?
Yes.
All right. So all you have to remember is what does the parent look like, right? We know that x squared functions are the parabolas. And we said if it's negative, then it should be opening down. So right away, you should get rid of anything opening upward. So B, C, D, E, F, G are not right, right? So it has to be A or H. Now, it's not shifted up or down or left and right. So it has to be A. Because check out H down here. They shifted it up and to the right. So it can't be H. Do you remember what caused the horizontal shifts and vertical shifts? Any questions on this first problem? There's not much to write out. It's just more of a conceptual. Okay, I'll move on then. Number two, this is in standard form. Um, can you tell what the vertex is by looking at it? Okay. You write some notes here for you. But for number one, just remember the graphs of parent functions. Recall or remember vertical slash horizontal shifts. Remember X and Y intercepts. All right, number two. Find the vertex and the axis of symmetry. G of X equal to X minus 8 squared plus 2. So remember the formula for f of x. We said you have this form. The vertex is HK, right? Axis of symmetry is x equal to h? All right. So our h is going to be 8. Our k is 2. So the vertex will be eight comma 2, and the axis of symmetry is the x value for this vertex. Any questions on number 2? Right. Just let me know. Number 3, let's see what this says. Can you see the graph?
Yes.
Okay, so they want to know the domain and range. Can you see that the domain will be all real numbers because it keeps going forever to the left and forever to the right? So eventually it hits all the x's way down there. So domain is always the x values. What is the range?
Isn't it the y?
Yeah, it's gonna be the y values. What's the lowest y value?
4.
Domain range. But it keeps going forever downward. So all the y's are included in the negative direction. So the lowest y would be negative infinity because it never stops anywhere. There's a highest point, right? Go domain, switch over. It's negative infinity to infinity. Range. Lowest number is negative infinity because it keeps going down. And the highest point it hits was a 4, right? So bracket. Any questions on number 3? Okay, cool. So far, seems easy, I hope. All right. Well, y'all tell me this one. Can you see the graph?
Yes.
So what is the domain for the parabola?
Infinity to negative infinity.
Yeah, it just keeps going, so that's right. Okay, so we'll write that down for domain. What about the range? That one's a little different. So let's always start with the lowest point. What is the lowest this time?
0.
Yeah, 0. So put a bracket and it keeps going upward. So it goes to infinity, right? Is that clear?
Yes.
Okay. So far, the tests feel like totally doable, right?
So far.
Okay. Can you see the new question?
Yes.
Let's write this one down. Just find the vertex of the parabola by applying the formula. The vertex formula f of x is equal to 2x squared minus 32x minus 72. Okay. Switch back here. All right. So vertex formula, since it's not in the standard form, we can find HK using this formula here. This is equal to negative b over 2a, comma, the function at that number, whatever that is. Oops, b. Okay. So we have a equal to 2, b equal to negative 32, and c equal to negative 72. So plug it in, right? H will be negative 32 over 2 times 2. That becomes positive. That becomes 4. Now, k will be simply the function at 4, which will be 2 times 4 squared minus 32 times 4 minus 72. That will be, oh, hold up. This should be 8. So vertex is simply the answer, right? 8 comma negative 200. Any questions on the formula? That's all they want you to do. Big deal yet. This is the same thing. I'm going to skip it unless you have an objection. Do this on the next page. Man. This is number 7, right?
I thought it was number 6.
6 I'm skipping,
Oh, sorry.
I think. Right. Double check. The last time we did was 5, right?
Yes.
Yeah, so we're skipping 6 and going to 7. Okay, y'all can see the question, right?
Yes.
Righty. So the child kicks a ball into the air. Height of the ball is y, or your function f, and it's approximated by this function. So t is time in seconds after the ball was kicked. To find maximum height, and how long will it take to reach maximum height? So basically all they're really asking is, what's the vertex of this parabola? Right, that's technically what they're asking, because the peak would be the maximum height. So that'll be the y value. How long would be the h, right? So h is the time, k is the height. So this is shift over. Models a ball through the air. It's going to keep it short. Y is equal to negative 16t squared plus 56t plus 3. All right. Okay. So part A, find max height of the ball. Part B, when does the ball hit that height? So this is my basically find the vertex HK, where this is time, and this is your height. All right. So H is equal to negative B over 2A, which is equal to negative 56 over 2 times negative 16. That'll be negative 56 over negative 32.
The 7/4.
7/4.
Yes. Or 1.75.
Okay. So there is the time, right, in seconds. Now, plug that time in to find your height when it happens. So K would be the function at 1.75 squared plus 56 times 1.75 plus 3.
52.
52. Was it in meters? I forgot.
I
Feet.
think it was feet.
Feet. But yeah, that's it. Just notice how it's really the same question. They're just applying it to something. So this is A is 52 feet. B is in 1.75 seconds. Any questions on number 7? Okay, let's move on then. That was number 7. Number 8 is the same, so I'll let y'all do that one. Same as number 7. Let's go to number 9. Okay, this is end behavior. They're calling it K. It's fine. This is equal to 11x to the 7 plus 9x squared plus 8x minus 7. Okay. we said we look at the total degree, right? If even, let me write that better. If the degree is even and the lead coefficient is positive, then we have this end behavior. So as x goes to the negative infinity, y would go to positive infinity. As x goes to positive infinity, y also still goes to positive infinity. Right? So that's number one. Number two, if the degree is even and the lead coefficient is negative, then it opens down. So as x goes to negative infinity, then so does y. As x goes to positive infinity, y also goes to negative infinity. If the degree is odd and the lead coefficient is positive, then we have this end behavior. Number four, if the degree is odd and the lead is negative, then it flips. Okay. So that's all you need to know for all of these questions. So what is this one? Is it odd or even, the degree?
Odd.
Yeah, it's odd, right? Because the highest power is 7. So you look at the 7. Leading coefficient is 11, right?
Yes.
And it's positive, so it has to be number 3. Number 3 says that as we go to the left, this also goes down. As you go to the right, it goes up. And I give you those little graphs and PDFs, you remember? But any questions on number 9?
Can you go back to where you wrote everything else? I wasn't done with the last sentence.
Oh yeah, you're good.
Thanks. Okay, thank you.
All right, let's look at 10. 10 is a little different, but you can count the factors up. There's 4 right here. There's 1 there, that's 5. 4 more would be 9. So 4 plus 1 plus 4 is 9. So this would be odd. Oh, but it's not asking for end behavior. My bad. But we could answer it that way. Okay, so it wants the zeros. You should be able to see the zeros by looking at it or setting it to 0. So we have, if we plug in 0 right there, we get a 0. If we plug in 1, we get a 0. If we plug in 2, we get another 0. Do y'all see how we got that? Big deal. All right. I'm gonna assume you're good. What is the multiplicity of the 0?
4.
0. 4. Multiplicity of the 1, 0. There's
Is that 0 or 1?
It's gonna be 1 because there's no number. So imaginary 1. And then 2.
Would be 4.
Yeah. Not too bad, right? So all they wanted was find the zeros. Since it was already factored, it's right there. And if you don't see it, you would set it to 0 and then solve it. There's nothing else to do there. Okay. On 11, you want to use all these clues to choose the right graph, or if you have a graphing calculator, then this will be easy. But just check all the zeros first. So it has to be touching 15. It's right there. This one's not touching 15, so it can't be B, right? Shoots off. This is touching 15. This one's not. So it has to be A and C. Now, we have 1, 2, 3, 4 factors. So if you were to multiply everything out, the highest degree will be 4. And the front is positive. So the end behavior is another clue you can use. This would be opening up, right? So it has to be A. Is that clear?
Yeah.
So yeah, just check the zeros and check the end behavior. That should be enough to choose the right answer. Same thing for 12. Okay. This one's 13. Simplify the expression. And state the restriction on the variable.
Is it y minus 2 and then y plus 4 minus y minus 2?
Let me see. Excuse me. Talking about the top part? This is gonna factor, right?
Yeah.
Y plus 2, y minus 2. This is the difference of squares. And then the bottom, is that the one you're looking at, or was it this one?
I wasn't too sure about the bottom one.
Okay, so here we factor using the AC method. So factors of -8 that add up to -2. So that would be plus 2 times y minus 4.
I was wrong.
And then double check. Yeah. These are canceled, so it reduces into this. You don't have to keep the parentheses, but you can. Yeah, there it is. Y minus 2 minus y minus 4. Now, the restrictions have to be the original. So look at the bottom of the original factor. Right here, see how there's y plus 2, y minus 4? So y cannot be -2, y cannot be 4 because of this one, this one. Because if you plug them in, you'll get 0 in the denominator, division by 0. Any questions on 13? Okay. So here's 14. This is a little different. Find the domain in interval notation.
Is that infinity or u for negative infinity?
Yeah, I think you're right. We have a problem at 4, right? So everything after is cool. Everything before is fine, but not at 4. So yeah, you create 2 separate intervals. So you said 4 to infinity over here. and then negative infinity all the way into 4. So write it in interval notation. Negative infinity to 4 combined with the 4 to infinity. Did you see how we have, because we have the division by 0, we just work around it? Is there any questions on 14? Does that make sense? Okay. $15. So here we have to factor the denominator. Probably grouping will work. Let me write this down and we'll shift over. Oh, come on. There it goes. So factor the denominator. These two have x squared in common, so factor out x squared. X minus 4. Factor out negative 9 out of these two. That'll give us x minus 4. So that'll be 2x plus 5. Factor x minus 4 out of both. That'll give us these factors. So we did grouping right here. Then we can factor further. Like this. So anything that makes the denominator 0 will be the asymptotes. So x equals to 4, x equals to negative 3 for this one, 4 for that one, x equals to 3. So this would be your equations for the vertical asymptotes. Do you have any questions on the factoring or that last step?
Nope.
So that's where they get this from. Okay. Equation of horizontal. Remember, I gave you a page, I think a worksheet about this. It said if the bottom degree is bigger, then your horizontal would be y equals to 0. And there is no slant. Find an equation of a function that meets the given conditions. All right. X-intercept, just write this down and we'll switch over. Three, 0, 1, 0. Vertical asymptote. X equals 4. Horizontal. One second. Horizontal. Y equals 1. Y-intercept. So we kind of have to work backwards. If the intercepts, that means there's zeros. So that means your function has to have x minus 1, because that would make it a 0. X minus 3 would make this a 0. If it has vertical asymptote x equal to 4, then I have to have one of these down here. Now, since the horizontal asymptote is 1, that means I have to have the same degree on the top and the bottom. So you kind of have to use all the ideas of asymptotes and intercepts all at the same time. So I would say there has to be a square here, because I can't put anything else down here. Otherwise, you'd have multiple vertical asymptotes. So the only way to make it degree 2 on the top and degree 2 on the bottom would be to make the x minus 4 a square type. Okay. The 0, 3/16. We might need that, but let's see if this is enough to kind of rule out some of the answers. So multiply this top part up here. The x squared minus 3x minus x plus 3. On the bottom, that'll be x squared. Oops. minus 8x plus 16. So let's see if any of them kind of look like this. Yeah, I'll see the questions still.
Yes. Will be the B or the second one.
Looks like it has to be the minus 4 plus 3, so that one's good. So A or C. Nope, not C. So not. Looks like only A is cool because it has to be minus 8 plus 16. Only these two have it. And the top part is wrong on B. So it should be A. Anyway, you see how we're kind of trying to work backwards. Are there any questions on this one? It's kind of weird, but you have to understand the zeros. And the vertical asymptote. This is in the denominator. This tells me the degrees of the numerator slash denominator are equal. So that's why I figured this out. So 17 and 18 are the same, so we'll stop here. Do you have any questions on any of these problems? Right.